Okay, today we're going to be doing systems of inequalities. We did graphing linear inequalities in the last chapter. A system of inequalities is where you have more than one linear inequality to combine. So slope-intercept form, mx plus b, we've gone over that several times. Compound inequalities, two inequalities joined by and or. Inequalities with an and must both be true. Inequalities with an or, neither one or the other must be true. We will be graphing compound linear inequalities as part of what we're doing today. Properties of inequalities, if you're trying to solve an inequality, everything is the same. Solving an inequality as it is an equation, except for flipping the inequality sign when you multiply or divide by a negative. Okay. Solution of system of inequalities, the set of all points for solutions of each inequality in the system. The solution must work for every inequality. If you're solving a system of equations, you can solve it algebraically and get x equals that and y equals this. And you can do that with a regular equation. With an inequality, you cannot do that. You cannot take it down to where x is less than this and y is greater than that. It's a combination of things. So just like when you're solving regular linear inequalities where you shaded, and that's what we're going to do, and you have that shaded region, we're going to have a region that is the solution to our system. Okay, we're going to have a region that is a solution. We're having an infinite number of solutions, an infinite number of xy coordinates that are our answers. But we're going to shade it. You can't really solve linear inequality systems without graphing. You can't do it without graphing. Okay? Any questions? Okay. Graph each system of inequalities. So the only way to solve a system of inequalities is to graph that system of inequalities. Now, this is another one where if you've got colored pencils or colored pens, it comes in really handy. Okay, it comes in really handy. It'll look nicer up here when I do it. So I graph the first one. I'm going to graph that inequality in red. This is in standard form, so I'm going to use standard form to graph it. Let x be 0. Negative y equals negative 3, so y equals 3. So my y-intercept is 3. Let y be 0, and I get 2x equals negative 3, so x equals negative 3/2, which is negative 1.5. Now, do I have a solid line or a dashed line? I have a solid line. And I have to test and shade. You do have to test and shade. So I pick the origin, put in 0 minus 0. Is 0 greater than negative 3? Yes. So that means it's everything on this side. Now, if you do not have colored pens or pencils, notice how I did. Now, because I can change my pen to a highlighter, and I can highlight, and I can fill in the whole thing if I really wanted to. Notice what I did. I did a nice little crosshatch kind of thing. I did lines coming off. If all you have is a pencil, I suggest you do this, and you'll see why when I do the second one. Okay. Now I do the second one. I graph it. This is an mx plus b form. That makes it easy. Y-intercept is 1. My slope is negative 1/2, so I go over 2 and down 1. And then I have a dashed line on this one. And then I have to test a point. This one does not go through the origin. 0 greater than 0 plus 1. Is 0 bigger than 1? No. So it's the other side of the line. Sorry. Here's the origin. So it's at the other side of the line. Okay. So you'll notice on here, I have solution to the first one. I have the solution to this other one. The solution to my system is the area where the two overlap. That's the solution to my system of inequalities. The red is the solution to my first inequality. The green is the solution to my second inequality. The place where they overlap is where everything works for both of them. That's the solution for my system. Now, like I said, because I did them in lines, not just in colors, but I did lines, the places where you have a crosshatch, that would be your solution area. Okay? When you're doing it on the quiz, when you're doing it on the test, shade that in a little bit. Okay? Indicate to me where the overlap is. And make it clear to me where the overlap is. Do the same thing on the next one. So I have my y-intercept is 2. 2y equals 4. Y-intercept is 2. I let y be 0. My x-intercept is 4. 1, 2, 3, 4. I have a solid line on this one. I test the origin 0, 0, 0 plus 0 less than 4. Yep, 0 is less than 4. So it's everything here. This one's an mx plus b form. My y-intercept is -1. My slope is -1. So for every one I go down, I go over. And this one should be a dashed line. And then I pick a point and test it. 0 greater than 0 minus 1. Is 0 greater than 0 minus 1? Yes. So it's everywhere on this side. Where's my overlap? It's a nice little wedge down the middle. Okay? You with me so far? It's not bad. If you can graph an inequality, you can graph a system of inequalities. You just don't get carried away shading really dark when you do that first one. Some students, man, they draw that line and they shade that first one, and man, they just take that pencil as hard as they can freaking rub it down there and make it as absolutely black as possible. And then they can't graph the second line, and they can't tell me where the two overlap. Be light. Don't get carried away. Some kids just have to be dark and mysterious. Okay. We got a new one. Compound inequality. That's why the compound inequality was on the beginning of the notes. X is between -3 and 5. So x equals lines are vertical lines. So I have one at -3 and one at 5. The one at 3 is a solid line. Sorry, -3 is a solid line. And the one at 5 is a dashed line. 1, 2, 3, 4, 5. And I want everything in between. It's not that hard to do. It's really a pretty easy graph to do. And we're going to be doing several of those over the next week or so. Absolute value inequalities. We've done them. Well, actually, we didn't do the absolute value inequality. Well, yeah, we did. We did do absolute value inequalities. Same idea, but remember we have a shortcut for graphing these. What does the -1 mean that I do? Move it to the right one. What does the -2 mean that I do? Go down 2. So my vertex moves from the origin over 1 and down 2. And this one is a dashed line. And then I test 0 less than absolute value of 0 minus 1 minus 2. This is 1. 1 minus 2 is -1. Is 0 less than -1? No. So the origin, which is inside the V, is not included. So that means everything outside the V is my shaded area. And where do the two overlap? This little wedge-shaped thing here. Okay? Does that make sense? It's just you do one, do the other, where do they overlap? Do one, do the other, where do they overlap? Next one, I have an inequality. We did this. X is less than or equal to 4. That means I have a line through 4, 1, 2, 3, 4, and it's solid. And I want everything less than that. And then I have my compound inequality. Y is between -6 and 2. So I have a line at y equals 2, and it's a solid one for that. -6, and it's a dashed one for that. 1, 2, 3, 4, 5, 6. And it's everything in between those two. And my overlap is this rectangular area. Graph one, graph the other, where are the overlaps? Not that hard, is it? I hope. Questions so far? Okay, your turn. Well, actually, yes, do the first one. Yeah, give both of these a try. Third one, how many equations do we have? 3. So how many colors are you going to need if you're using colored pencils? 3. If you're not using colored pencils, then you have to figure out making sure that you shade properly so you do that. Go ahead and give both of those a try. Okay, let's go ahead and do these. So the first one's a compound inequality. Y is between -1 and 4. 4 is solid, 1, 2, 3, 4. -1 is dashed. And y is in between. And then I have a linear inequality, my straight line. Let x be 0, my y-intercept is 2. Let y be 0, and I get -4/3, which is -1 1/3, so just a little bit past 1 in the negative. And then I have a dashed line for that. And I test the origin, 0, 0, less than 4 is 0, less than 4. Yes, so I shade here. In my joint area, there's this nice little wedge in there. Next one, I have 3. So I'll do the first one. X is greater than or equal to 0. Well, that's 0 on the x-axis. Or sorry, my bad. 0 on the y. 0 on the x-axis is the y-axis. And I want everything larger than that. So everything to the right of that. That eliminates half of the work. Do x, y intercepts for the next one. My y-intercept is 6. 1, 2, 3, 4, 5, 6. My x-intercept is 4. 1, 2, 3, 4. And I have a dashed line between them. Test the origin. 0 plus 0 less than 12. 0 is less than 12. So it's everywhere here. So right now I have this little triangular space. When I have to do the last one, I don't have anything with the x, so it stays, so it doesn't move left to right, and the -2 means I'll move everything down 2. So it goes here to 2, and it's a dashed line going up. And I plug in 0, 0 greater than absolute value of 0 minus 2. Yes, 0 is greater than -2. So it's everything inside the V. So my solution area is right in here. That little triangular space. Okay. And that's okay. We can have lots of them. It's just where they overlap. What about if they don't overlap? What if they don't overlap? Be no solution. It happens. Okay, be prepared. Your turn. Do those. Okay, it looks like most everybody's finished. So let's go ahead and do these. You do them one at a time. First one, let x equal 0, so y is equal to 3. Y-intercept is 3. When y is 0, my x-intercept is -1. I have a dashed line. I plug in 0 and 0. 0 is less than 3, so it's everywhere on this side of the line. Next one, my x and y-intercept both are -1. So y-intercept is -1, x-intercept is -1. Once again, I have a dashed line. Plug in 0, 0 plus 0 greater than -1. It is. So it's everywhere here. And then I do my last one. X is less than 2. So I want to have a solid line on 2. And I want everywhere less than that. So my area is this triangle. Right in there. My overlap area of the three of them. Next one, same thing. First one, absolute value of x, negative x. Just take the absolute value of x and flip it over. I can't test the origin because it goes through the origin. Pick another point. I just like to pick one I know for sure isn't on there. I'm going to use 0, 2. 0 for x, 2 for y. Is 2 greater than 0? Yeah. So that means it's everywhere above this. Do the next one. X is between 2 and -4. 1, 2, 3, 4. 4 is dashed. 2 is solid. And I want everywhere in between. So right now I'm looking kind of like that wedge shape, depending upon what the last one is. And the last one, y is greater than or equal to -5. 1, 2, 3, 4, 5. And everywhere above that, it doesn't really affect, the last one doesn't really affect anything because it's still just this shape. Right in there. Okay. Any questions? Okay. Awesome sauce.